Hi grade 9s, welcome back to another one of our video lessons. So today we're going to continue on page 127. We're going to look at quadrilaterals and the different properties of the different quadrilaterals that we can have. Okay guys, remember in the previous lesson we went through the different types of angles we have. We looked at different triangles and how we classify them, and you guys had to do exercise 13.1. Now we can continue on page 127. Okay. In grade 8, you classified quadrilaterals based on their sides and angles. The table is a summary of the properties you should already know. Okay, so I'm going to run through these. I want you to follow me in your textbooks, so page 127. Okay, so the first figure we have is a parallelogram. Okay, remember all of these are quadrilaterals, meaning they have four sides, but four-sided figures can all be different. Okay, so first one is a parallelogram, so it's essentially almost like a rectangle, but it has been kind of slanted onto one of the sides. Okay, so if you imagine a rectangle has 90-degree angles, this one has just been pushed over a little bit, so we don't have 90-degree angles anymore. Okay, what are the properties of this quadrilateral? Well, this side equals to that side, this side equals to that side. This side is parallel to that, these two sides are parallel as well. And also, we know that our opposite angles of quadrilaterals equal, or rather of a parallelogram. So these two are the same, and these two are the same. Okay. Right, so in this table it summarizes it quite nicely for you. So both pairs opposite sides are parallel, both pairs of opposite sides are equal, and both pairs of opposite angles are equal. Okay, so guys, when I say, I could give you a question, I could say, right, this is a parallelogram. Okay, find certain things. You need to know that if I say it's a parallelogram, then all of these characteristics or properties do apply, and you have to use that in order to solve the question. Okay, right, let's go to the next one, a rectangle. So a rectangle, well guys, you know what a rectangle is. It's almost like a parallelogram, but it has 90-degree angles like that. Okay, so 90-degree angles everywhere. Opposite sides are equal and parallel. Okay, and all the angles in a rectangle are equal. They are all 90 degrees. Okay, the next shape we're looking at is a rhombus. So a rhombus is similar to a parallelogram because it's also a shape that has been slanted over. So a rhombus is similar also to a square. Why? Because in a rhombus all the sides are equal. Okay, looks like a skew rhombus over here. Let me make it a little bit better. Okay. So rhombus, all the sides are equal, and again, opposite angles are the same. So that equals to that equals to that, and we have parallel lines as well. Okay. Right, the next one is a square. So think of a square as a right-angled rhombus. Okay, so all the sides are the same. These are parallel. These are parallel, and all the angles are now 90 degrees. Okay, so a rectangle and a parallelogram are almost the same. It's just that one has been pushed over, and the same thing goes with square and a rhombus. Okay, right, let's go to the next one. The next shape is a trapezium. Now, the properties of a trapezium merely just tell us that one pair of opposite sides is parallel. That's all we know. So one pair of opposite sides is parallel, there it is. The other two sides, we have nothing, well, we're not told anything about it. Okay, apart from that these two sides are parallel. So it says one pair of opposite sides parallel. Isosceles trapezium has non-parallel sides equal. Okay, so an isosceles trapezium is a trapezium where these two sides are equal. So if we have that these two are the same, we have an isosceles trapezium. But if they are not the same, then we just have a trapezium. Okay. Right, and then the last figure we have is a kite. Okay, so properties of a kite, we have two adjacent sides that are the same, or two pairs of adjacent sides that are equal. So here's our kite. The two adjacent sides are these two. Okay, these are the same. And these two are the same. Okay. There's another property here, is that where the two sides meet that are not the same, so at this point and at this point, these two angles are the same. Okay, so those two angles are the same, those two lines are the same, and those two are the same. Okay. Two pairs of adjacent sides equal and angles opposite symmetry line. Okay, so they're talking about a symmetry line being down the middle like that. So they're saying angles opposite the symmetry line are the same angles. Okay. Right, guys, so you are required to know all the properties of these quadrilaterals. You have to be able to use them to solve problems. Okay, so now let's look at exercise 13.2. I'll do one or two with you, and the rest you guys are going to do for homework. Right, so it says solve for x and or y where necessary, and then classify each quadrilateral. Reasons must be given. Quadrilaterals have not been drawn according to scale. So don't try to look at this picture and figure out visually what it is. We have to get the missing values, and then based on that, we're going to figure out what's going on. Okay, so here's my first shape. Okay, it looks like that. They say this side equals to that side. This side is 5. This side equals to that side. This side is 12. The diagonal is 13. And this angle is x. Okay, this thing is called A, B, C, D. Okay. Right, so that's the information they give us. They want us to find the missing values, and they want us to classify this quadrilateral. All right, well, let's see what we have. We have two opposite sides are the same, two opposite sides are the same. Okay. Right, well, what can we do? Okay, we need to figure out whether this angle x is a 90 or not. If it's a 90, that means that this is a rectangle of sorts, because the sides are not the same, so it can't be a square, it can't be a rhombus, okay, because the sides are different. So it could either be a parallelogram or maybe a rectangle, okay, depending on the sides. Okay, so now this x, how are we going to figure out what that value of x is? Okay, well, we need to figure out if our theorem of Pythagoras works. Okay, so that's one way to test it. Remember, if this angle is 90, then in this triangle, Pythagoras will hold. Well, let's check if it holds. If it holds, then the angle is 90. If it doesn't hold, then the angle is not 90. And if the angle is not 90, we know it's a parallelogram. Okay, so let's test the Pythagoras, right? So 5 squared plus 12 squared equals 2. 5 times 5 is 25 plus 144, which equals 2. 169. Okay, what about 13 squared? 13 squared equals 2. It is also 169. Okay, do you see that both values are 169? That must mean that our value x is 90 degrees. Okay. Well, if that's 90 degrees, it means that, remember, opposite angles are equal. Okay, so if that's 90 as well, okay, well, remember, we have to justify this. So we have to say that 5 squared plus 12 squared equals to 13 squared. Okay, therefore, angle x equals to 90 degrees. The reason for this is converse of the Pythagoras theorem. Let's see what they They don't have a worked example here, so we can say, let me actually check in the teacher's guide to write the correct reason. Actually, we can even see it in the textbook at the back. Just want to make sure it's the right thing. Okay guys, sorry for that. So I looked up the reason. So the reason for this is converse of the Pythagoras theorem. So because we're using it backwards. Okay, so we'll write converse of Pythagoras. Okay, so converse of Pythagoras. That's the reason. That's how we concluded that x is 90. Because 5 squared plus 12 squared equals to 13 squared. Okay. Right, so we know that this is 90. Okay. So we can redraw this thing as like this. Okay, that's a 90. This is 12, that's 12. This is 5, that's 5. Okay, we have a diagonal that does that, which is 13. Okay, so what do they want us to find out? Well, if that's 90, then that's 90. And opposite angles are 90, so everything is 90. Okay, so what kind of shape is this? It is a rectangle. Okay, I think in the answer it says it's a parallelogram, but I would disagree that it's a parallelogram because it has an angle of 90 degrees. So I would say it's a rectangle. All right, guys, so let's look at number 2. Okay, so number 2 has something like this. Okay, guys, so this is what they have. So they've given us a quadrilateral, they've divided it into 2 triangles, and they've gave us values of all the angles, right? But the values include x's and y's, and we have to solve this, right? Okay, now there's 2 ways to do it, or rather there's only one way, but there's 2 ideas that we can think about, right? So we can look at the entire quad and say that, well, if we add all the angles in the quad, they have to add up to 360 degrees. But the problem with that is that we have x's and y's. So we won't be able to solve for the unknown because there's 2 unknowns in our equation. So we can't solve for one in terms of the other. We need to have only one unknown and we can solve for that. So that takes us to the next step where we're going to look at each triangle in turn. Okay? So if we look at this triangle, we see that it's all x's. If we look at this triangle, it's all y's. Okay? Well, we know that all the angles in a triangle add up to 180 degrees. Okay, well, let's do that. Okay, so let me just get the letters here. E, H, G, F. Right, so what we can say is in triangle EGH. Okay, it's nice to let the marker or whoever is looking at your work to see which triangle we are working in. So in this triangle, we have that 3x minus 15 plus 2x plus 8x equals to 180 degrees. Okay, what's the reason for that? The reason for that is sum angles of triangle. Okay. Now let's add up all the x's. 3x plus 2x is 5x plus 8x is 13x equals to 180 plus 15. So it will be 195 degrees. Okay, now we're going to divide by 13. Okay, I just want to check if that's correct. It seems right. 13x plus, okay. We divide by 13, divide by 13, and we get x equal to, let me check what 195 is divided by 13. Okay, the answer is 15. Okay, so x is 15 degrees. Okay, right, the next one we can deal with the second triangle, and the idea is going to be exactly the same. Okay, the reason is the same. So in triangle now EFG, okay, what do we have? Same story. 3y plus 5 plus 2y plus y plus 25 degrees all has to equal to 180 degrees. Again, angles of the triangle add up to 180 degrees. Same reason as before. Okay, 3y plus 2y is 5y plus y, that's 6y equals to 180. So here we have 5 degrees plus 25, that's 30. Take it to the other side, it becomes negative 30, so it will be 150 degrees. Right, now we divide by 6 to get rid of that coefficient. Y equals 150 divided by 6 will be 35 degrees. Okay, 120 divided by 6 is 20. No, I'm lying, it's 25, not 35. Okay. Right, so that's x and y, but remember we're not done because they said classify this quadrilateral. Okay, so what we're going to do is now we're going to fit all the values back into here instead of x's and y's, and based on the angles of this of these two triangles, we're going to figure out what we are looking at. Okay, so let's do that. Y equals to 25, so 2y, that's going to give me an angle of 50 degrees. Okay, 3y is going to be 75 plus 5. This is 80 degrees. Okay, y plus 25, 25 and 25. This will give us 50 degrees. Okay, cool. Let's do the x's. We found that x was, what was it? It was 15. Okay, so 8x is what? 8 times 10 is 80. 8 times 5 is 40. So 80 plus 40 is 120. Okay. 2x is 30. And 3x is 45 minus 15, which is also 30. Okay, so now we have all our angles. Let's now look at the different angles in each triangle the same, and let's remember guys, when we classify in quadrilaterals, it's not just about the angles, it's also about the sides, okay, whether they're all the same or not. It would either give us a rhombus or a square or a rectangle and a parallelogram. But now the trick here is that we can use the triangles and the angles to figure out if the sides are the same, because we have isosceles, we've got equilateral and so on. So here you can see that 30 degrees here and 30 degrees here, opposite sides are the same. So that equals to that. All right. Now we have 50 and 50. That means that opposite sides are also the same. But we don't know if they are the same as that. Okay, we don't have no info. We just know that these two are the same like that. All right. So we got one pair of same sides here, another pair of same sides there. All right. Well, let's now also look at our angles, right? None of our angles are the same apart from these two, okay? These two are not the same. So what kind of shape are we looking at here, okay? Well, firstly, there's no 90 degrees, so it can't be square or rectangle, okay? There's nothing saying about parallel sides anywhere, okay? So we can't really, well, we know that these two are not parallel because of alt angles, okay? 30 and 50 doesn't give us an alt angle, which is the same. So these lines are not parallel. Okay, if the lines are not parallel, it could either be a trapezium where one pair of lines is parallel, so we can check it this way, or we can check it this way. Okay, this way, checking the other two sides, they are also not parallel because these angles are not the same. So this leaves me with the conclusion that this must be a kite. Why do I say that? Well, we have two pairs of opposite sides that are equal, or rather adjacent sides. So these two are the same, these two are the same. And we have opposite angles over here being the same. You see, there's no other information apart from saying that there's no parallel lines. So the fact that there's no parallel lines already excludes a lot of the options that we could potentially have. So I'll conclude that this is a kite. X was 15 degrees and Y is 25 degrees. Okay, you can't see it there. I can show you X 15, Y 25. Alright guys, so that's how we need to go through this process and explain what these things are. So obviously when you're justifying what kind of shape it is, you need to explain to me why you're saying that. Okay, and the explanation is that we have pair of adjacent sides equal, another pair equal, and opposite angles over here are the same. Okay. Cool guys, I want you to look at the rest of exercise 13.2, and in the next lesson I'll continue with quadrilaterals and their diagonal properties, and we'll get to exercise 13.3. Okay, I hope you enjoyed the lesson and I'll see you next time.